Hi, folks. Greetings from the Great White North, Canada. It's actually beautiful outside right now, about 26 degrees Celsius and sunny, so I cannot complain. So let's just dive right into this. My plan for this video is to teach you about the rock cycle. My favorite teacher in high school was my grade 10 biology teacher, Mr. Hunter. He was a major influence as to why I wanted to become a teacher myself. That and Bill Nye, the science guy, absolute legend, but I digress. Let's jump straight into this. So the rock cycle, I'm sure everyone here is familiar with that. The first thing I'm going to do is describe the types of rocks that are in this cycle. So firstly, we have sedimentary rock, which is represented by the yellow starburst. We have metamorphic rock, which is represented by the red, and igneous, which is represented by the orange. So firstly, let's define these. So sedimentary rock. These rocks are formed from a combination of existing rock sediment and organic material. Metamorphic, these rocks are changed from their original form through immense heat and pressure. The heat and pressure, which I'm going to demonstrate using a Ziploc bag and my grade 12 yearbook. I'm sure I'll do just fine. And finally, we have igneous rock. Boom. Which is derived from the Latin word fire and is formed from melting, cooling, and solidifying. All right, so before we get into the actual cycle, I also want to describe the actions that are placed on these rocks and why it creates the rock that they do. So we have compaction and cementation, we have heat and pressure, melting and cooling, and weathering and erosion. So before we begin, I also want to let you know that at any point in this cycle, that stone or rock can be reverted back to sediments, which are a bunch of chopped up starburst right here through weathering and erosion. So whether you are at the final stage being igneous, through weathering and erosion, it can revert back to sediment, metamorphic, or even sediment itself. It all can revert back to that very primary stage, which is sediment. So let's begin. So sediments, which are small pieces of any rock type I mentioned above, and organic material that have been stripped from their original form through weathering and erosion, as I have right here. And it's making my fingers very sticky. These sediments, pieces of starburst, through forces of compaction and cementation over many years, will create sedimentary rock. So I'm going to use my hands. You can just imagine them being the plate tectonics crushing down, or just layers and layers and layers of sediment on top of this sediment, pushing down, crunching it back over many, many years. So we'll demonstrate right here. This is very sticky. You can roll it. Oh, it's actually not doing a really good job. Probably could have warmed this up a little bit more. Oh, there we go. All right, so it is not the greatest representation. Probably could have left the starburst out of the fridge for a while. So here, this is what we have. This is a metamorphic rock, a sedimentary rock. So through compaction and cementation, the sediments, the very smallest particles of all these different rocks, are crushed and pushed together, and you get something like this. So I mean, something similar to sandstone. Now, as we move forward, I don't want to touch my scroll pad. There we go. So now we want to imagine this piece of sandstone represented by the starburst. This sandstone is underneath many other layers of sediment and rock. This sandstone might experience immense heat and pressure, which again over many years will yield metamorphic rock. So as I mentioned earlier, your sedimentary rock right here is under thousands and thousands of pounds of other rock and debris warming up underneath the crust of the earth, folding over itself over and over again, experiencing all that heat and pressure, which is represented by this plastic bag. So let's take that out and let's Boom. All right. So now we have metamorphic rock. The metamorphic rock is slightly different from the sedimentary rock, as it's obviously more compacted. It's been under many, many layers of sediment, and through that heat, that extreme heat and pressure, all of those sediments have been packed together even tighter. Similar to Damascus seal in a sense, where it's been folded over itself many, many, many times. Now, into its final form. And this I skipped because I had to heat it up. So now that we have the Starburst, which is actually now metamorphic rock right here, metamorphic rock that ends up underneath the Earth's crust can be exposed to heat that is above its melting point. Subsequently, that metamorphic rock will turn into magma. So the common misconception that magma is below the Earth's crust, lava is above. So when that metamorphic rock has gone above its boiling point, it will melt. And once it melts and cools, it will turn into something that looks like this, which is igneous rock. So once that magma travels closer to the surface, it cools, and thus we have created a starburst igneous rock. So like I said before, sedimentary rock was right here, metamorphic rock right here, igneous rock right here. But through weathering and erosion, it can all revert back to sediments right here. Now the best part about this little lesson is that you got to eat them afterwards. Thanks, folks.